All right, everyone. Thank you for joining us today for our latest topic of our live Q&A called Helm hacks. A little housekeeping before we begin. My name is Tim Stahl. I'm the head of pre-sales North America here at Appia, and I'm joined by my colleague Salman. And I'll let you introduce yourself.
Hey, everybody. It's nice to see you. My name is Salman Iqbal, and I don't exactly know what my title is, but it's solutions engineer. That means I've been with Appia for a little while, and I work as a solutions engineer, working with the clients of Appia and on the other projects too, just developing stuff. So I've been working with Kubernetes for the last 3.5, 4 years. Definitely feels a lot longer than that because of all the issues that you have to deal with Kubernetes. And I'm a developer at heart, so I've been a developer for a while. But yeah, I've been working with Kubernetes and containers for, I'm gonna say, like almost 4 years now. Maybe a little bit longer, but 4 years. I have experience of working with Kubernetes in production in different environments.
Awesome. And I've gone ahead, because this is a live Q&A, again, a little bit of housekeeping here. I will enable where you do have the ability to ask questions throughout. I do ask if you wouldn't mind, just raise your hand so we know to pause for a minute and allow you to come off mute. But that being said, I am monitoring the Q&A and the chat windows. So feel free at any time, if you have something you don't want to, just kind of blurt it out, feel free to throw it in there and we'll address them as we go. So that being said, though, Salman, I'm going to turn over to you, let you share your screen, and let's get this going.
Let's get it going. So give me a second. You gotta let me know if you can see the screen, the correct one, because I have been known to not share my screen.
I don't see Slack. I see the slides, so we're good.
You see the slides? All right, perfect. Yeah, excellent. You don't see any of the memes, which might not be the best thing. So excellent. Well, thank you very much, Tim, for a great introduction. So yeah, we're going to talk about Helm hacks. So we'll share some tips on Helm. But before we can do any of that, I'll take a few minutes explaining what Helm is. Mainly, we're going to talk about how you can create a Helm chart and the need for it, and how we can make the best use of Helm as delivering and packaging applications and delivering them. But before we can get anywhere, thanks to Appia for organizing this event, appia.io. We got really cool blogs online. You can check out on appia.io under resources, and we do some other stuff that you can have a look at when you get a chance. So the aim for Helm, the aim of Helm is to deploy and share applications consistently. Well, what do I mean by that? Because let's have a look at, before we can do that, this is about Kubernetes. Well, what is Kubernetes? Kubernetes is a platform that enables, as an open source software, as you all aware, enables us to orchestrate containers, manage containers, run them, stop them, scale them, and all kind of stuff. So Kubernetes itself is quite massive, but it's important to focus on the apps that we actually deploy. So what does an app in Kubernetes usually look like? We'll explain that first, and then we'll talk about why do we need something like Helm. If you look at the slide that I put in front of you, what you see at the bottom of the screen is pods. Pods are, as you're aware, where we run our applications. So this is where containers will be running. A pod could have one or multiple containers. Usually we don't just deploy pods, we deploy what are known as deployments. The purpose of deployment is to say what kind of pod you like to deploy and how many replicas you like it to run. And that just watches over the desired state that you asked for it to have. So if one of the pod crashes, it'll bring it back up automatically, so we don't have to worry about that. Now, in order for an application to be accessible, what we need to have is something called a service. And a service is an abstraction that sits on top of pods. I like to think of it as an internal load balancer, because you could have multiple replicas of an application running. And if there's multiple replicas of an application running, which one do you pick to send the request to? And this is where service, I know a lot of things are called service in computer science and software engineering, but this is Kubernetes' own terminology. This is where service comes in. Service acts as the internal load balancer, but that's all internal to the Kubernetes cluster. But what if you want to send the traffic from outside of the cluster to inside of the cluster? And this is where we bring Ingress in. So Ingress is, as it says on here, an external load balancer. Again, a Kubernetes resource. And what it allows you to do is send some traffic from outside to inside the cluster And you can route it based on the request that you make. So for example, if somebody sends a request to /checkout, send them to a specific service. Or if somebody says a specific domain name, send them to a specific service. That's what an ingress is. So this is at a very high level what an application might look like, a pod with a service and an ingress, and people will be able to access it from outside of the cluster. But this is not where the story ends, because usually an app doesn't just have an ingress and a service and a pod. There's a lot of other configuration that goes with it. And all of this stuff is created using YAML files. And I'm sure you've seen the YAML files, and I'm going to show you some examples of it in a few minutes. They don't have to be YAML files, but we usually use YAML files to create them. And if you're working with microservices, which is the purpose of this talk as well, then we all end up with a lot of applications, a lot of components. For example, this one app in here that I'm showing you, you can see in the bottom left, there's config maps, there's deployments, there's ingress, there's namespace, there's secrets, all of this stuff that you'd require for this application to run. What can I do? How can I deploy this app if I wanted to inside a Kubernetes cluster, a cluster that I might have? Well, there's a number of options. I can use the command line tool, or I can run it via my pipelines. I can take any of these files. I can do kubectl apply -f, whatever the file is, deployment.yaml, service.yaml, ingress.yaml. But I'm deploying them all individually. If I have an application, I might be doing this across multiple files. I don't have to just do file by file. I can do at a directory level. Like I said, just apply the whole directory. That's fine if you're applying it, but what if there was a slightly better way of doing it? And what if you wanted to deploy these files, but maybe with a slightly different configuration when you're going in UAT, in production environment, in development environment? For example, maybe the number of replicas that you wanted to have in development was a lot lower than number of replicas you wanted to have in production. What do? Do you have the same file? Do you copy the same file and you create separate files for different environments? Not, you can do that, but it becomes a bit cumbersome. This is an example. Or, for example, you wanted to inject a sidecar container in every pod. What is a sidecar container? Sidecar container in a pod? Well, what you can do is this. Imagine this is a pod YAML. I'm sure you've seen this before. We've got this bit that says kind pod. And at the bottom, you can see this container section. And the container sections, we have images. This is one image that we're running. We're just running this Nginx image. That's all. But what if I wanted to inject a sidecar container, let's say an Envoy container, into every pod that's getting deployed inside an application, maybe a different one in different a different environment? If I want to do that, how can I do it? And this is where templating comes in handy. And also, what if I wanted to roll back everything? So right now I can deploy things separately. Well, that's absolutely fine. I can take each of those YAML files, I can apply them, and that'll work. But if I want to roll back, how do I know which files I should roll back? Right now, if you deploy an application on your laptop or anything like that, if you're Windows, you can get installers. You just run the installer, it installs everything. If you want to uninstall, you go into the Windows laptop, the add and remove program, uninstall everything. What if there was a way of deploying an application as a package and just rolling it back when you needed to, if there's a mistake or if something didn't quite work?
So what you're saying here is I could do this way, but now I've got to have a folder for dev, a folder for UAT, a folder for
Correct.
prod, all those YAMLs in, and then every time I change it, then I'm going to have to manage what version it is, or I'm going to have to use
Correct.
a repo to check it in. That sounds like a pain.
Absolutely right. Absolutely right. And yeah, I don't have like a consistent way of rolling stuff out, right? So I don't have a package and I have different environments. Even if I don't have different environments, if I only have one environment, I still got to release everything one after the other, right? And if something breaks, I want to be like, you know what? I want to go back to how we were, let's say 20 minutes ago. How do you do that? Well, maybe I changed the service. You can look at a change control and see what changes you made. Maybe I changed the service. Maybe I didn't change the service. Maybe I changed the ingress. This way, as a package, I can deploy it, just make changes. And if it didn't work, I can roll back previous versions. And we'll see how Helm can help us do that. I'm just building a case for what I'm about to show you here. And also, what you can do is create templates that people can reuse across the organization. And what if there was other packages created by others that you wanted to install in your cluster? For example, if you want to run Redis inside Kubernetes, Redis is a key value store. So a database just stores key and a value. What if you wanted to install Redis inside Kubernetes? How does that work? Well, there will be a Redis container. That's fine. But you have to write the deployment file. You have to write your ingress or service and any of the other configuration that it might require. You can write it all yourself, have the right values in it, do the right mapping, make sure everything's correct, and deploy it. Or you can install it using a package or what we call a Helm chart, right? That's a package.
Ah, there it is. You buried the lead.
Yeah, I can deploy it using that. Or, Tim can say, look, as an organization, we want to run a tool very consistently throughout. For example, RabbitMQ. It's an MQ queuing, so messages can get queued up and subscribers can pull these messages from the queue. And if we wanted to deploy it consistently across the whole organization, we would create a Helm chart and give it to the organization and say, if anybody wants to deploy it, this is a chart you can deploy, a package you can deploy. So that's where Helm comes in. Helm is an open source tool. It's written in Go, and it uses Sprig templating library to be able to package your applications that way. What are the main things in Helm? And what does it actually look like? Well, first of all, Helm itself is a command line tool, and it uses your kubeconfig. So when you're using kubectl, you will have some permissions to be able to do something in the cluster. You can create some resources, you can delete some resources, you can list them or whatever you need to do. So Helm is a command line tool that you install in your cluster, install on your machine or in your pipeline if it's using it, and it uses your kubectl configuration to deploy stuff. So it has the same permissions as what you might have. And then people talk about charts, and charts are just packages that contain, you can think of charts as zip files that contains all the resources that define how to run an application. Your deployment files, your ingress files, your service files, your configuration files, I don't know, volumes, PVCs, replicas, or whatever you have. Everything is inside the chart that you need to do it. And we'll look at the chart in a second, what it looks like. And then where do you store these charts? Once the charts have been created, of course, you can do it locally on your machine and everything's fine. You can run it, you can install it, you can deploy stuff, you can play around, but that's not where you get most of the benefit. You want to be able to share these charts across your team, through the whole world, whatever you might be doing. And this is where registries come in. So you can use things like Chart Museum, or you can use, like in GitHub as well, you can store charts. Most of the container registries allow you to store charts. If you wanted to use like a zero container registry to store your chart, you can do that. And this is where a registry comes in, pretty much like a container registry you can think of, like Docker Hub, where you can go and look for your containers. You can go to chart registries and look for charts that you can deploy. And then what you can do, and this is perhaps the most useful thing, which is what we were saying, is if I can release things as a package, I can also keep a history of things. This is what Helm does. It keeps a history of your releases, which allows you to roll back if you needed to, and not if you didn't want to. So you can have like a version release of things across. So you can go version 1.0.0, 1.0.1, and if you wanted to roll back, you can roll back because Helm keeps a history of everything that you've released inside Kubernetes itself. That's where it keeps it. Okay.
I'm glad you answered that. I was going to ask you where it stored it.
Yeah. Actually, if you want a bit more detail, so inside Kubernetes, in Kubernetes itself, as you're aware, there's a control plane and there's worker nodes. And control plane has all the components that are required to run Kubernetes. And one of the components is that etcd database, which stores all the desired state configuration, all the state of the Kubernetes cluster. and it stores in this information in etcd. Inside secrets. So secrets get stored in etcd also. This gets stored in etcd too, this information.
Very cool. Very cool.
Yeah, so that's where it gets stored in. Didn't used to be that way. It was slightly different in the previous version, but now this is the case. And I'm glad I answered your question. I knew it was going to come. That's why I included in the chat.
It's
in the
almost like
slides.
you teed me up for it.
It's just like that people watching it. I knew it was going to come. But feel free, everybody, all the attendees, please feel free to ask any questions. If I'm going too slow, too fast, let us know in the chat. This is a chat, so I hope you're finding this useful so far. These are just some examples I've put, like there's chart registries available online, repositories, sorry, not registries, repositories available online, like Chart Museum, Harbor. You can set your own up, and you can find others that are out there that you can do. So that's a bit of a background on why we need Helm and how we can use it. But what does it actually look like when I talked about, oh, well, you know, I want to have a Helm chart, but I want to have different configuration and different environments. How do I do that? That was the first thing I said, right? Oh, I got, you have configuration files, for example. This looks like a deployment file, and I as an IIS deployment. Doesn't matter what kind of deployment it is. This is just like a Windows example that I'm showing you here. So it's a deployment file in here. And then in here, you might see, I'll put another slide up to the next. What you want to do is have some variables that I can replace. For example, in this case, you can see the var on the right, the one that's in pink. That's the bit we want to replace. And Helm understands that. If you start something with 2 curly braces and ends with 2 curly braces, this is like a placeholder that you can use to replace the value of it. For example, we want to change the number of replicas in a given environment. In dev, we only want to keep 3. Maybe in production, we want to have 5 or 7 or whatever it might be. And then if you start with these curly braces, and we'll look at exactly what you put inside. Don't really put var, you put values, whatever the name of the environment variable is. But that's basically a placeholder for Kubernetes, sorry, for Helm to understand how to replace it. But how does Helm actually do the replacement? In order to do that, we need to understand how Helm actually works. Basically, what you have is a cluster, and it's a Kubernetes cluster. And in the cluster, when you want to talk to the Kubernetes cluster, you talk to what's known as the Kubernetes API. It's like just good practices. Everything should talk to everything via an API. Even inside Kubernetes, all components talk to all components via an API. So you have this Kubernetes cluster. You can talk to it via an API. And usually your kubectl command line tool connects to Kubernetes and talks to the API directly with your configuration, with your permissions. And what you do is you install the Helm client on your laptop. Let's say we're going to talk about our laptop because that's the easiest thing to think of at this moment. And then what you do is there's a chart repository somewhere, and it could be, you could connect to multiple chart repositories. And this is just like connecting to, let's say, you know, you have, you connect to Docker Hub to pull images, or you connect to Google Container Registry to pull images. It's basically like that. You can add chart repositories to the Helm client and let it know this is a chart repository that's available. And then what you can do is you can get, you know, you can search some charts on there, and then you can take that chart, whatever it might be, and submit that to the Kubernetes cluster and install it. How do you install this to Kubernetes cluster? What does all of this look like? Well, let me show you an example. For example, you are in a cluster and some charts have been installed. I'm just going to show you some commands now rather than doing it live. I just thought I'll put some slides up just to show you them. Imagine if you wanted to see, are there any charts already been installed in the cluster? There's some commands which are quite useful. You can do Helm ls. You connect to a cluster, it's going to list all the charts, all the installers that you've installed. This is like going to your Windows add and remove program to see what applications have been installed, or in your Mac, going in the applications folder to see what's been installed. This is what it will show. This will show you all the list of things that have been installed. And then, you know, where do these charts actually come from? They come from repositories, and you can connect to multiple repositories if you need. So you can list what repositories that you might have. So you can do a Helm repo list, and it will list all the repositories that you might be connected to. What if you wanted to connect to the repository that wasn't listed? Well, this is how you can do that. It's quite straightforward. You can do Helm, repo, add. You give it a name. In this case, I called it Bitnami, and we have a full URL of the chart repository. And then this will basically add that repository and say all the charts there inside the repository are available for you to run. Excuse me, available for you once you're connected. You can do Helm search repo Bitnami. So that's the name of the repository. Now, there's a typo in here, and I left it on purpose to see if somebody was gonna
I caught it. I wasn't going to say anything, but I definitely caught it.
Somebody's gonna notice it, but definitely something I need to update. But but this is going to list you all the available charts, and you can also pass the names of things that you're looking for. Let's say if you're just looking for MySQL charts, you can do Helm search MySQL, and it's going to give you a list of MySQL charts that might be available. And this is just looking at one specific repo, but if you don't specify that, it's going to list you everything else that might be there. So everybody with me so far? Does it all make sense? I'm gonna guess. Okay, thumbs up from Tim. I can't see other people. I'm sure they're giving me a thumbs up too. So I hope that's okay. So how, once you've listed the charts that are packaged and already available for you, how do you install it in your cluster? Well, as you can imagine, there's an install command, and this is what you do. You can say Helm install, and you give it a name. So I'm giving it a name Zoo, and then the name of the chart. And then, so this is Helm install Zoo, but Bitnami Zookeeper. It's an Apache's project. Let's say it's going to install some configuration.
And actually, we've got a question here.
Okay.
Feel free to unmute. I see you have your hand up. Feel free to unmute and ask away. Oh, I see a couple hands up.
Okay. Feel free, unmute and ask away.
Yeah. If you have a question, please, we'd love to hear it. You could put it in the chat, the Q&A, or you could just unmute yourself and.
Okay.
Well, if you think of it, please put it in the chat or let us know.
Put it in the chat. Whatever. If it's a meme you'd like to share, absolutely, I'd love to see it. If there's a question as well, please feel free. Please feel free. Okay, excellent. So these charts we can install, but the good thing about these charts, as we talked about before, was some variables that you can replace, right? We said, oh, there's some variables you can replace. You can set them later on if you want to. Okay, I think there might be a question. Oh, could we have slides after the session? Sure. I think, do we have registration when people register with an email address? So
we do. And what I'll do is I'll send you, please email me, and I'm going to send you my email address. So please just reach out to me, and I'll be more than happy to get those to you after the conclusion of the webinar. Yeah,
perfect. Yeah, if you stick your email in, Tim, for people to use, if people like, Tim is gonna send out the email, send out the slides afterwards. No problem whatsoever. Okay. Right. We can. I mean, they're Google slides. Maybe we can share it at the end, right?
And actually, so we're actually going to send them out to everyone who attended.
Oh, perfect. Okay, so whoever attended, they will get it. Perfect. Excellent. Thank you very much. Yeah, no worries. People will definitely get these slides. No problem whatsoever. Okay. So yeah, you will definitely get the slides. No worries. Excellent. Any other questions? Good. I like that kind of question. I don't have to think too much. Can you send us slides? Of course we can. No problem whatsoever. Okay, excellent. So what we've got now is some charts that we can lift. So just a bit of a recap so far. What we discussed is there's a bit of work that you need to do if you need to deploy applications in Kubernetes, because there's a lot of components you have to write your configuration for. Your deployment files, your ingress files, your YAML files, that you keep writing, and then you can keep releasing them. But sometimes you deploy them with slightly different configurations as well. Let's say number of replicas you want to have different in dev, then you want to have different in UAT, then in production. So how do you do that? Well, you can have multiple files for different environments, but that's not really the most efficient way. Maybe you can have a placeholder. Also, we want to have a consistent way of packaging an application and releasing it as one whole package rather than separate components. And this is where Helm comes in, and Helm allows us to package an application and deploy it as a release. And this is what you're seeing right now. You can get charts that have already been packaged. So the whole thing that just, I was going to say just works, but sometimes it doesn't just work. You have to configure some things. You can take a package and deploy it. And this is what you're seeing here. We're installing Zookeeper. And at the same time, some of those variables that we talked about in the beginning that you can replace using this bit here with --set. And I'm setting replicas equals to. And how do you see what variables are available? We'll talk about that in a second. And once you install it, it will deploy things in your cluster. For example, if it needs to create any service accounts, it will create them. Or it needs to create any deployments with pods, it will create them. Everything that your application needs, it will create. And then, based on the release name that you see, you can do a history of what's actually happened. Oh, we released this chart, and this is the version of the chart. The installation is complete. And now you have this list, and anything that you do afterwards to this release is additive. That history doesn't get like removed or anything like that. It keeps adding, you keep adding to the history. So if you ever want to go back to a specific point, you can, and that's sometimes quite useful. So what if you wanted to, there was a new version of the chart, right? The new version has been released and you want to upgrade. Well, again, it's kind of straightforward. You can do this Helm upgrade Bitnami Zookeeper. This will take you to the latest version, whatever the latest version is. You can also install a specific version, which I'll talk to you about in a second. And then you can, once it's updated, it'll go ahead and do its thing. Maybe the container image was updated, the deployment file was new, maybe the service was changed, something has happened. And all the release that happened, it just updated the whole thing as a package. And then if you check the history, you will see a number of, you see 2 entries instead of just 1. And that's kind of useful because of if you ever wanted to go back, as I was saying before. What if you wanted to install a specific version of a chart that was available? Maybe you didn't want to go to the latest version, maybe you want to go to the specific one. Well, straightforward. You can upgrade to a given version, -- version 6.9.3, depending on, the chart itself will tell you what version that you're using. And I'll show you some examples in a sec.
I was going to say that's something that tripped me up initially was the version it's asking for here is the chart version, not the application version.
Not the application
You have to
version,
look
indeed.
and see which,
Absolutely. This is very good point there, Tim. This is the chart version. The application version is inside your deployment files and whatever it might be. This is the version of the chart. Sometimes it might match with the version of the application. Not most times it won't. So this is, you have to look in the charts.yaml file, which we'll talk about in a second. That gives you the right version. So yeah, I'm glad you raised that point there, Tim.
Yeah, okay, that's personal experience right there. me fighting at the keyboard for an hour until I realized, oh.
Yeah, fair enough. So I've got these different versions now I've deployed. I've been able to deploy. What if I wanted to roll back to a previous version? For example, I've got these 2 versions here. This is just a super simple example. I've got Helm history Zoo, go from version 1 to version 2. And then let's say I wanted to roll back the previous version. I can do Helm rollback Zoo, that's the name of the release, roll back to the previous version. And then if you did Helm history Zoo again, and that will say is, this is additive changes as we're talking about. We don't go back. It doesn't really delete the previous one. It just goes, it's been rolled back to the previous version. And that's what that does. Now, there's a couple of things I should raise here. Usually, when we work in software, we say we should fix forward rather than roll back. And that's a good practice to have because you want to make a fix via pipelines, who you change in, and be able to release quickly to fix it. That's good practice. But sometimes you might be using a chart that's been provided you by a separate team, by a different team, or it's a chart that you got from a chart repository online and you are deploying in your cluster. And you don't have this ability to fix it forward because you don't own the code. And what do you do in that case? Well, the best thing to do is roll back to the previous one that was working. That's why it's kind of useful. And also, one of the good tips I would say is, because it's a chart, you have to treat it like any other package that you install, anywhere, software package. If you don't just install any package. Imagine you're in Python you're using PyPy, you won't just go ahead and install a package in production straight away because you don't know
Wait,
what's
what?
in that package.
Wait, you're supposed to test them first? Ah, what fun is that?
I know. Sorry, I'm being Mr. Killjoy here, but that's what we're doing. So you wouldn't really want it to put it in production or in an environment that you think it can affect is something else because we don't know what's in it. Just like any package they install. So you might want to create a sandbox environment. For example, you create a virtual environment in Python and you'll install it in your package in there, test it out, see exactly what's going on in there. Understanding what's in the chart is also a similar thing. You can maybe open the charts, GitHub directory, GitHub repository if it's available, see what it does. Or one of the best things to do is use one of the tools where you can spin up your clusters locally. Tools like Minikube or Kind, Kubernetes, and Docker, where you can spin up a cluster, test out just that chart, see does it create the things that you expect it to create, how does it behave, does it work well, and then you can bring it into your environment. So that basically test it out in sandbox environment. Is that, I'm sure that's what you do, Tim, as well, right?
Yeah, sometimes.
Test stuff
I like to
out.
live dangerously.
Absolutely.
This is also why nobody lets me near their cluster.
No, I've seen your work. It's good. It's good work. It's good work. Okay, so this is using somebody else's chart that's available, and that's great. And it makes a lot of things easier. Let's say if I want to have WordPress, if I want to install in a cluster, I can just go and install on as a chart. A lot of projects that you see that are Kubernetes related are, if you go on their GitHub repositories or in their documentations, they'll tell you can install it as a number of, you can apply the YAML file, or you can install it using the Helm chart. And that's kind of useful because you can just go in and, as you saw, with one command, you can install the whole thing. What if you wanted to create your own chart? What kind of things do you require? Well, a collection of files in the directory we need to have that describes Kubernetes resources. That's what we need to have. So we need to have all the files that that are that make the application. So deployment, service ingress, and all of that. And then what we need is so the templates that we write, they're based on Go, and you'll see some of the templating stuff in a second in Sprig library. That'll hopefully explain why some of the YAML files end up looking a little bit weird. But I'll explain that in a second. And then you can release based on numbering version. As you saw before, we've got this major minus patch, the semantic versioning. And also you can create your own chart, but let's say your chart depends on another component. Like, for example, the application requires a MySQL server to run. So you can, of course, create your MySQL server to run in the cluster, or you can have that chart dependency on another chart, for example, MySQL chart. And that'll be kind of cool because you don't have to do that yourself, and it'll just automatically create that for us. Not automatically, but it's going to go through the list. So how do you create a chart? Well, if you're trying to create a chart locally, we have a question from Hadir. I think maybe we can answer this question. So my own chart is public or private that can only be accessed from a certain person. Yes, absolutely correct. So if I understood your question correctly, the question is, if I have chart, is it public or private? Can I have permissions on it so only specific people can access? Yes, that's correct. It's like container repositories, container registry, in which you can have a public repository so everybody can have access, or you can have a private repository and you can give people access to that repository, depending on how you configured it, where you configure this chart repository. So you can have it in your, let's say, in your GitHub or in your container registry or in Chart Museum. You can do either of those, and you can give specific people access to those to that repository so they can pull a push. I hope that answers the question, Hadir. Let me know if it doesn't, and then we can talk about a little bit more. Cool. It's an excellent question. Very good. Nice. Right. Next, what we're going to talk about is how do I create my own chart that I can share, with others. Well, you can start with installing the Helm client on your laptop. So you can check out, if you just type Helm on your browser, it'll take you to the repository. just type Helm Kubernetes, and it'll give you an option of how to install it on your machine. It's quite straightforward. Once it's there, you can do Helm create, name of the chart, give it any name. Excuse me, I just called it my chart. And what it will do, it will create all the necessary files that you require to create a Helm chart. And the files will look like this. There's a directory structure. If we open it, there's going to be a bunch of files. And this is very useful because all it's done is giving me the template of the things that I can put in. For example, I can have the chart.yaml file. In the chart.yaml file, I can have, let's say I have, well, there's a bunch of files in here. There's a chart.yaml file. Chart.yaml file just has information about the chart itself. For example, what version it's using and what kind of other dependencies that might have on. Like, I said charts can have dependencies on other charts. There's nothing more special in there. The only thing there is just the name and the version, if I have any dependencies or any other charts. That's the chart.yaml file. And then you have this templates folder, and then you have this charts folder as well, just before templates. This is going to bring in all the charts that we set are in dependencies and put them in that charts folder, the one in dependencies. And then we have the templates folder, and the templates folder includes all the files that we expect our Kubernetes resources to have. For example, it will have a service file, and it will have a deployment file. And in the deployment file, you see we've got this placeholder, which is like highlighted in pink. We have this values of replicas, saying how many replicas we want this application to have. And we can replace it with some values. And how do we replace this? Well, we make those available in what's known as a values.yaml file. That's the default configuration values for that chart. So if you open the values.yaml file, you see some information in there. And I'll show you in a second, what does that look like? So you saw in the deployment, there's the deployment. We've got some replicas that we have, right? So what happens next? Well, what if I want to have a different environment variable, different value for different environments? Well, there's a few things you can do. You can have multiple files with different values, and you can apply different files for different environments. And that's one way of doing it. Or you can use a --set flag, as I was showing you a few slides ago, to set the environment variable. And if you open the values.yaml file, the values.yaml is the default one. So if you do Helm install, it will look into values.yaml, or you can pass in a file, the values-uat using the -f flag, the values-prod. Imagine you're deploying a different environments, you can do that, and it will replace it with different values in different environments. That's how we do the templating. And then you have this helpers.tpl file. So that they basically the templates that you can reuse throughout the chart. For example, in this case, you want to, you create a chart name and a version that's used to be that's used by the chart label. So you can use this templates file. I think there's another question. This means that these default templates created by default once I create a new chart. Yeah, so I think Hadir's question is the templates created by default once I create a new chart. Yes.
Yeah, like all of these, in this case, place boulders.
Yeah, place boulders. Good spot there, Tim. And I love the use of your annotation. Yeah. So the question is, all of these files, are these created by default? Yes. I think I might have added a couple here just to show you an example. But some files get created by default. You don't have to use them. You can go ahead and delete them out of your own file. It's entirely up to you. You can name them whatever you like. It doesn't make any difference whatsoever. You don't have to call them deployment. You don't have to call them ingress. Helm is smart enough to figure out which kind of resources you're creating, because in the YAML file itself, it will say the API version it's using and the kind of resources it's using, right? So it's going to look at all of that. And then it will generate, you look at YAML file, it will generate your actual YAML that you're going to submit to the cluster and submit it to the cluster in memory. So it doesn't generate a new file, just takes that and submits it. So I hope that answers your question. That's a good question. Again, very good.
No, it is. Yeah, because you could name it, 123.yaml, and it's
you can stick everything in one file as well. It doesn't matter. Yeah. It's entirely up to you. But yes, that's what it does. It does create you these by default, not exactly these by default, but some of them. Yes, that's right. If you have your YAML files, you stick them in your templates folder. And if there's any changes you need to make, for example, you need to add in like some placeholders that you need to replace. You can replace them, but yeah, they go in that folder. So all your YAML files will go in that templates for this templates folder, and they will go in there. And then you can add the default values in the values.yaml file. If you have multiple ones, you don't have to add this multiple files. You can ask people to replace the values with whatever value they like, and then you can just submit the cluster. You can use any file name for anything. That's no worries. The only thing you have to be careful of is chart.yaml has to be charts.yaml. The charts folder has to be charts folder. The templates folder has to be templates folder, and everything else can be renamed. Hope that explains. All right, we're almost coming to the end. I know we've been going on for a little while. So, and the chart directory contains all of the charts that currently the charts depend on. So, what you can do is then you can create the chart using Helm create my chart. So that's what we did previously. Yes, that's correct. So the question from Adira is: values YAML files are required, or can I set constant values in the deployment? You can set constant values in the deployment, but if you want them to be replaced, you can, of course, you don't have to. Like, for example, in this case, I'll show you if I understand your question correctly. The question is, can I set constant values in the YAML? Like, for example, you can see this container port is constant, right? It's not changing. So I can stick that as is. But if you expect people to replace this, any value that they might be running with that chart, you can stick that in a values.yaml file. If it's in the values.yaml file, that means you have to have this as in your YAML files as values.replicas or whatever the environment variable name is, and then they'll be able to modify it when they're deploying in their environments. And that's what that is. I hope that's the question. Is that, Tim, did I get that?
Because in that case, you would have the the default or the constant value. Like, let's use container port, for example.
Yeah.
The constant value in this case would be 80. If you wanted it to be able to change it easily, you could actually go in and put like the values let's see here, selector.spec containers container ports container port, and you could have that set there, so that way you could easily change it. You could have a default value, but you could also pass in a value when you deploy the chart as well with the -- set.
Yeah, there's a question from Yavor that says, can we look at how value files are, can we look at how a value file looks like? That's an excellent question. Let's have a look at real value file. How about that, right? So just so you know, this is an actual live demo and not the one that we've recorded before, right? This is real life. So let me bring my browser up and we will do some stuff. Oh, why is it not coming up? Okay, so let me show you an example. Let me bring my screen up here in a sec, if I can grab it. Okay, so if we look at, let's say I'm gonna look at, what are we gonna go for? We're gonna look at Nginx Helm charts in GitHub. So this is a Helm chart that you can use to deploy. Is this the one? Stable? No, give me a sec.
I say it is in there, but you gotta have to dial down into it so much that.
No, 1 minute, 1 minute. There's a better.
Yeah.
Okay, so this is a Ingress Nginx controller that you can use to deploy. So if I can go in, let me see if I can find I'll find a Helm chart in a second.
I think it's right. The charts and Nginx, charts Ingress Nginx.
Oh, perfect. Excellent. Good spot there. Good spot there, Tim. So if you look at this values.yaml file, and as Tim was talking about earlier on, this is what it will look like. And these are the kind of bits that are available. For example, things like image, information about the image, like, oh, this is an image that you can replace. And these are the bits that you'll define inside the values that need to be replaced in your Kubernetes configuration files. So this is what a values.yaml file looks like. Again, some of the stuff, you don't have to replace anything. You can just pass it blank, and you can just use that itself. I hope that answers your question, Yavor. So the first question is, values file are not mandatory and can be removed. I think, oh no worries. So the question is, are you saying are values file mandatory and can be removed? I think that you don't have to have values file. If it is, you'll use that as a default. You don't have to have the values file. I hope that answers your question.
Oh, perfect. Yep.
Perfect. Okay. Excellent. Very good. We had some good discussion here. Excellent. I like it. I like it. Okay, so almost coming to an end. We can, like I just gave you a little bit of an example here. You can have it, but we saw a real one, which was even better. Ben, I'll answer your question. Okay, give me a second. I'll answer that in a second. Ben's got a really good question. I'll answer it. I'll finish off the slides and we'll answer it in a second. Okay, so we got all our chart. If I wanted to create it, this is what you do. You can Helm create chart, as we we're saying, we'll create a directory. And once this is ready, you can install using Helm install my chart dash app, my chart dash f values.yaml. And you can install also, once it's installed, you can do a Helm history and see what's been released. And then you can check all the resources that have been created. You get the kubectl, get all, and see everything that's been created for that specific, just to verify if anything, what are you expecting was created or not. So here's the thing. Let's answer Ben's question because we're going here. So for example, Ben has a really good question. So you can override the values of dependency charts and values.yaml, as just we talked about. That's fine. But how do you override the deployment YAML in the dependency chart? Like you want to add a sidecar image in your own chart, but just to expand the deployment file. And this is where this helpers.template file comes in handy. And there's a bunch of examples out there. If you Google like add sidecar container using Helm templates, it all comes up. And this is where this templates file comes in handy. And you would define what kind of template you're trying to do, and then this will go ahead and create the bit that you need to do, like for the sidecar bit, if you wanted to add that in there. And then you can reference this helper in your deployment file to pull the information that you require, and you can add it in there, whatever. Like this one, for example, this is a template that we create for like the chart name that's going to use the version and the chart name by the label. So that can then get referenced and can get generated in the YAML file. So you can define a template and then reference a template to be able to create that. I should have added that example in here, but that's a very good spot. What I'll do is before we send the slides out, I'll add an example for that in here just so you can see it. So Tim will do that before you send out. So I'll make sure we add that in there. Just to how do we add the sidecar stuff? I hope that answers your question to some extent for now. Okay, cool. That's a very good question. So a couple of things before we finish off. You saw the command line tool. That's fine. People love command line tools, and I love it too. Everything works. But sometimes it might be easier to not install things using command line. Maybe you want to do using maybe a UI tool, because not everybody in the organization is going to be comfortable with installing apps using command line tools. Or you just want to see what's available. So there's some dashboards that you can deploy on your cluster. For example, there's one called kubeapps. If you search for kubeapps, it's a tool that gets deployed in your cluster, and that will look at your Helm configuration, and it can like what repositories you're connected to, whatever is available in that Helm configuration. I'll make all the things that are available inside the chart to you in the UI, and you can click on these buttons, and then it will show you like these are the charts that are available. Show all the values that you can modify, all the things that you can use, and you can modify them, and you can install them using the UI rather than using the command line tool. This might, again, different tools for different use cases. So this is something that could be beneficial. This is another tool which is kind of similar, but it's quite new from a company called Commodore, and they have this Helm dashboard. And you can see in this case, you can install this metric server as a Helm chart, and it also shows you the kind of resources you are deploying at the same time, which is useful because it's telling you you're going to create a service account, and this is the resource tab. We're going to create a service account, cluster roles, role bindings, and all that stuff. And then also it's going to show you, if you click on the other tabs, like what values you're applying, what manifest has been created. So that's something that's kind of neat.
Yeah, that's cool. I've seen Cube apps. I hadn't seen that one yet. So
Yeah,
that
this
looks
quite this is quite new actually. I think they released it last week, something like that.
ah,
So it is it is a useful one. I've used it really briefly. It seems okay. It seems like a very good tool. So something to check out. So quick summary. I know we've been going on for a little while. So Helm is a command line tool that uses a kubectl configuration to deploy applications. So it doesn't create a new file. It will generate the file in memory and just submit it to, based on the template that you set, and submit it to the cluster. And we create packages like Helm charts to contain like all the resource definitions that we have to create our resources become a chart, and we can place charts in a repository and they can be shared, and we can release them as using the Helm release. So we have a version release and we can roll back if we ever wanted to roll back. That is all I wanted to cover. Just check out app.io. We got like a bunch of blogs on there and a bunch of things on there. We're going to be doing this very regularly. So I think same time, same place.
yeah.
Next week. No, same place, because it could be a different link, right? I
Yeah.
think.
At the same time. And we'll have Graham next time too. So we'll
have Graham next time. So yeah.
Way.
We're going to talk about next week. We're going to talk about like how do you debug issues in Kubernetes, because Tim, what happens with Kubernetes?
It goes wrong.
Absolutely. And if there's any suggestions of any topics you'd like us to cover, we're going to talk about how do you debug issues in Kubernetes next week. We're going to be doing this weekly now. From now on, we're just talking about different topics. But before we do any of that, I really want to thank all of you for joining in and asking all the questions. You asked some awesome questions. We hope you found it useful. You can definitely send us some feedback, even in here, or email us. You can find me on Twitter as well. I didn't put my Twitter handle up, Salman Iqbal, or you can just email it to us on our email addresses. But really, thank you so much for joining in. I know you take time out of your day to listen in. I hope you find this session useful. Thanks from me. I don't know, Tim, you want to add anything?
Yeah, no, thank you so much. I agree, and we'll look forward to seeing you next week.